Well, to solve this problem here, we can either go from the left and on a journey from the left-hand side to the right-hand side, and then we proved the trig identity, or we can go from the right-hand side to the left-hand side, and that will thereby prove the trig identity, or we can go from the left into the middle, so to speak, and the right, and join. As long as we join up, we've proved the left is equal to the right. So these are the three sort of options we've got, and we can do this question in various ways. If we were just looking at the left and looked at the top, you can see that if I times the top by another of those, I'll get the square of it. And if I times the bottom by, so let's do that then and see what happens, because the bottom is going to turn out to be the difference between two squares. So if I put a bracket around the top and simply times top and bottom by cos minus sine x, so here, so we've got our left hand side like so, and then we times it by this number here again, so we get a square of it, so cos x minus sine x. But we can't change the number, so we've got to put a cos x minus sine x underneath, of course. Then the top is now okay, because the top will equal cos minus sine, this bracket times itself twice, which is cos x minus sine x, that object squared, isn't it? That's what that is. Now this bracket underneath, let's have a look what we've got. We've got cos squared, so I'll put it in here if I've got room. We've got minus sine squared, excuse me, I've got a bit of a cold here. And then we've got a plus and a minus, because it's a difference between two squares. So this would be, see the middle term? So the first term was cos squared. Then you have minus sine cos plus sine cos, see it, the second and third term. And they cancel each other out, because this is the plus and the minus, a difference between two squares. And then the last term is sine times sine is sine squared, plus times a minus is a minus. And the cos squared can be replaced by 1 minus sine squared then. So I know I'm dragging this out, because it's a lot easier than I'm basically saying. Cos squared is 1 minus sine squared. Put it in. We've also got a minus, so it's simply 1 minus 2 sine squared. That's that. Now you could do it the other ways around. We went from left to right, but we could look to go from right to left, because you could write this as this bracket here, and you could then say that that was the difference between two squares, and then you could cancel top and bottom one of the cos x's minus sine x's, thereby getting the top number in the numerator on the left hand side. So, but traditionally you would go from left to right in this example. So here's the solution.